Okay, we are on to lesson 4.3 and 4.4. Now there are three different ways that we can write our linear equations in. The first is slope-intercept form. Okay, that one is y equals mx plus b. That is probably the one that you are most familiar with. The second is standard form. And that one is ax plus by equals c. Generally, when you are given an equation, it's given to you in standard form. And the third one is point slope form, which we will go over the formula for point slope form in just a second. In order to write an equation in point slope form, it's useful when we're given the point and the slope, hence it being called point slope form. And that's going to look like this: y minus y1, so that's part of the point, equals m, which is our slope, times x minus x1. So you're going to fill in for y1, x1, and m. And that's all you're going to do here. So example 1 says write an equation in point slope form for a line with a slope of 2 that goes through the point 10, 7. So we've identified our m as 2. Our x1 is going to be the x coordinate, which is 10, and our y1 is going to be the y coordinate, which is 7. So we are quite literally just going to fill in to our equation. So y minus y1, which is 7, equals m, which is 2, times x minus x1, which is 10. And that is it. When I ask you to put something in point slope form, you are going to stop here. Okay, point slope form. This is what it looks like. Example 2. Let's identify a point and a slope. The slope they give us is 2/3. The point they give us is -1/3. So my x1 is -1 and my y1 is 3. So let's follow our formula. Y minus y1, which is 3, equals m, which is 2/3, times x minus x1, which in this case is -1. You can change this to a positive if you wish, because minus a minus will give us a positive. That is as simple as it gets for point slope form. Example 4, however, says write the equation of a line that goes through the points. We want you to do it in point slope form. Well, the two things you need to write an equation in point slope form are a point and a slope. But you don't have the slope. You have a point. You actually have 2 points that you can choose from. It doesn't matter which one you use. But you do not have the slope of the line. But you can find the slope of the line using the 2 points that were given to you. We find the slope using our slope formula. -2 minus 5, y2 minus y1, over x2, -1 minus x1, which is 3. So -2 minus 5 is -7, over -1 minus 3 is -4. That becomes +7 over 4. I'm not done yet because I have not written my equation in point slope form. Remember, point slope form is simple. All you need is a point and a slope, and now we have a slope. We also have a point. We actually have 2 points that we can choose from. Does not matter which point you choose, your answer may look different than the person next to you. I'm going to choose the first point for my x1 and y1. So I get y minus y1, which is 5, equals my m, which is 7/4, parenthesis, x minus x1, which is 3. Moving on to graphing equations in slope or point slope form. When you're graphing equations in point slope form, you need to first identify what it is that the equation is giving you, okay? So for this first one, we know that the number in front of the parentheses represents the slope. So our m is going to be 1/2. Let's also identify the point that they're giving us. Remember, when you plug into the equation, y minus y1 equals m times x minus x1, you are supposed to be subtracting the point. So since our 2 is positive, it actually means that our point is -2, right? Because if we were to plug that in, if we're working backwards, we were to plug that into our equation, it'd be minus a minus, therefore it actually becomes a plus. So we're working backwards here. Our other part of our point, which is our y value, well, that's negative, so the 3 is actually going to be positive. Okay, because when you plug it in, it becomes the opposite sign of the actual coordinate. So the first thing you're going to do is plot that coordinate. Go -2 up 3, and then all you're going to do is apply the slope. We know this point is on the line. We don't need the y-intercept. We can graph it with just a point and a slope. We're going to go up 1 over 2, up 1 over 2. So plot your point and apply your slope. Going from point slope form to slope intercept form. Well, in order to get something in slope intercept form, you need to solve for y. Okay, that's always what you want to do, is solve for y. Well, in this case, we have y minus 7 equals 2 times x minus 10. Before we can solve for y, we need to do some distribution here, because there's parentheses. So distribute, and we get y minus 7 equals 2x minus 20. Now we should be able to solve for y. Well, what's happening to y is that it's being subtracted by 7. So in order to get it to the other side, you need to add 7. Now if you notice, it's going to cancel over here. You cannot add 7 to 2x, but you can add 7 to -20 because they have the same terms. So -20 plus 7 is -13. Now you have put something from point slope form into slope intercept form, which hopefully you can identify the slope and the y-intercept now that you have this in slope intercept form. You would do the same thing with example 6. Distribute the 2/3 and solve for y. Last thing that we're going to go through, and this can be pretty difficult to grasp, says we can also write equations of lines in standard form. This is oftentimes the most difficult form to write lines in. Okay, pretty much when you write equations in standard form, your first step is to get your x and y's to the same side. And then your second step is to get rid of fractions. You cannot have a fraction when you are dealing with standard form. So example 7 says write y equals 4x plus 2 in standard form. Reminder, standard form always goes ax plus by equals c. So let's get the x's and y's to the same side and get the numbers to the other side. Let's subtract 4x from both sides. So we get y minus 4x equals 2. Well, we're very close, but doesn't quite look like what we want it to look like up here. So what we need to do is do some rearranging. Instead of y and then negative 4x, we need to have negative 4x plus y equals 2. At this point, we don't have any fractions for our x's and our y's, so that's it. Example 8 says write the standard form equation of a line passing through that point with a slope of negative 2. Well, we can always put in point slope form first and then rearrange so that it is in standard form. So let's start with that. Our point slope form, reminder, is y minus y1 equals m times x minus x1. It says write the standard form. So we're going to start by actually writing the point slope form. So y minus y1, which is 3, equals m, which is negative 2, times x minus x1, which is negative 4, which actually becomes a positive 4. From here, distribute, get all of the x's and y's to one side and the numbers to the other side. So we distribute. We get y minus 3 equals negative 2x minus 8. If I wanted to put this in slope-intercept form, I would just have one more step to go. I would have to add 3 to the other side. But I want this equation in standard form, okay, where it goes ax plus by equals c. So I'm going to do some switching around here. I want the numbers on one side and the variables on the other side. So I'm going to add 2x. So I get 2x plus y minus 3 equals negative 8. And then I want to get that negative 3 to the other side. So I have 2x plus y equals negative 5.